Welcome to statistics. Started 3.2 for this video. Sorry, I let you guys out. If you're concerned about like how fast the first couple of weeks go, caution you to say the first couple of weeks do go rather, mostly because the material is not that intense. For the people who are a little bit bored, I promise you it will get harder. For the people who are panicking a little bit, it's harder. I'm going to let you know that trying to make some room so that we have space to slow down chapters 5, 6, 7. That's where it gets a little bit. But first stuff, saying isn't something to get used to, but yeah, you'll see. We're going to start going through it. You'll see. Need extensions on things, don't be afraid to ask them. That seems like it's too dark. See. All right, so I'm going to share the screen. There we go. Share the screen. Actually, I'm going to share the whole screen. Stop share. Share everything. There we go. All right. So we're just going to start here. I have a calculator emulator that we're going to use a lot. I would honestly recommend you get a TI-83, 84. Check them out if you really need them. For your homework, you can use an emulator. You can use your phone. It's fine. But I would recommend using the emulator phone because when you get to the quizzes, you're not going to have can't let you have a device that connects to the internet and computer, which is locked down. So we are going to work out just the calculators here. Okay. Do your environment checks. We're going to say, hey, I got a calculator. Yep, you sure do. You should have one. So here we go. Now it's the right size again. Okay, so let's just start off here. We're going to start off with measures of scrap. And there are 3 measures of scrap. So the first one is called the range. You'll like the range. It's the biggest value versus the smallest value. So it's the maximum value minus the minimum value. So if we have something like temperatures, right, over a certain month, and maybe the high temp for the month, so 8 degrees Fahrenheit. The temperature for the month, 16 degrees Fahrenheit. Then the range, and I like to rate the range as this. I like to rate 90, 60 is equal to 30. I like to write this whole expression as the range. The answer that you're, if you're taking a standardized test or something, you're giving homework answer, they want 38. Okay, they don't want to see this. But I think letting people know like what the values were is a nice thing because statistics we care a lot about where the values are. 98 minus 60 is a 38, it's a 38 difference, but so is this. And that's like if you were testing a stove or something, you might get this temperature, but it's still 38. Right? Or these are way different numbers, even though they do all have the same range. So I like to tell people where the number came from and how we got it, so that they know the min and the max, and they can see where the. But in every case, if I had this on a standardized test or doing something to connect, the answer that they want 38, 38. Let's do it. You're telling a human being, like, What's the range? Oh, it's 30, it's 98 minus 60 to 38 range. So 1090 minus 160 to 1060 to 38. This might be like somebody's correct or something. That's the context for that. All right, 2, standard deviation. And I'm going to address variance in the same spot. Okay, standard deviation and variance are very similar. Standard deviation is actually the square root variance. So variance is the standard deviation squared. So standard deviation squared is equal to STD is equal to your variance. The book will ask you for the variance in the homework. There's an outcome you're supposed to learn for the class, but I've noticed that most people, when they are at the 100 level stats class, 200 level stats class, they don't really work with variance all that often. So, Sam, I'm never really going to ask you what the variance is. I will ask you the standard deviation. Okay, now, if you have ever heard from somebody that statistics is a scary class and it's hard, it's awkward. This is the reason why. It's this formula. So a standard deviation have population standard deviation. Okay, and a population will be all the objects of interest. Okay, so if I wanted to know, say, like, I want to know all the gas mileages of the cars in Colorado. The population will be all of the cars' gas mileages in Colorado. That includes the cars that haven't used since the Carter administration. It includes every car that's there, even if they've been up on blocks for the past 4 years. Okay, it still has a gas mileage you need to know. That's for population. For a sample, population versus sample. Sample is some of the gas mileages in there. That could be 1,000, it could be 2,000, 10,000. The sample could be a big number, but it isn't all of them. So it maybe, I don't know if they have emissions testing in Colorado, but if they did, and you got the gas mileage for everybody who brought their car in for emissions test during June, that would be a sample. Okay, it's not all the cars, it's just the ones that happen to come in emissions in June. We like to work with samples because they're easier to collect. But when it comes to standard deviation, we have 2 different formulas. We have a population standard deviation and a sample standard deviation. Okay? So the formula for the population standard deviation. Okay? Now, we use different symbols. The population numbers are usually Greek. So we use this, use capital, it's a small sigma. This is a Greek letter, sigma. Okay. Some people like to write it like that. They write a little hat on it. I like to write mine as like a sideways 6. Okay. But however, neither of these have a good authority that this is not as correct as this is. But this is easier for me to write, so that's how I do it. We also use a capital sigma. This is also a sigma, but this is like a capital letter sigma, just like in English, right? We have a capital letter and a little letter. Sigma and capital sigma, they look a little different. We're going to use U. So sigma, this is our symbol for standard deviation. Capital sigma, this means the sum. Okay, all it means is add up all the stuff that comes after it. Okay. Mu, this is our population average. Okay, so we're just going to add up all the numbers and then divide by the number that we've added. It's pronounced mu. And we use a capital N. So this is the number of things. This is the number defendants in the population. Right? So I'm trying to be real careful, like for all the symbols I'm going to use, but what do they stand for, and what, you know, if you've not, I don't think that you've seen them before, like what are their names? So we're going to do this more and more often. We'll always go through the whole review for it. You know that. Okay. So those are the symbols we're going to use. And here's the formula I deal with. So we're going to say sigma equals, okay? We're going to take each observation. Okay? So xi, the I just means like 1, 2, or 3. So the first observation, the second observation, the third observation. What was the high temperature in June on the first day? What was the high temperature in June on the second day? What's the high temperature in June on the? That's what these numbers are. Okay, it's just the first, second, third, fourth, fifth, dot, dot, dot. Okay. Minus the average. Then we're going to square those numbers. And we're going to add them up. Then we're going to divide by the total. And then we're going to take the square root of the whole thing. So 2 things about this. I stopped giving this formula. Don't have to memorize it. Do not memorize the formula. Because people start using it. We're going to do it by hand once. And then after that, I'm going to show you how to calculate this number in the calculator, because we don't want to do this every time. But if you have a parent who took statistics when they went to school, probably didn't have a calculator that was capable of getting this number. So back like in the 80s, we had to do all of this by hand. Okay, which is why statistics has such a terrible reputation. Because if you can imagine we're going to do it with 5 numbers. They're going to do it by hand like every time. So that's why that's terrible. So there's our formula. We're also going to work with this is the population, so for all of them. Then we have our sample, which we will prefer to work with, but we use S. Okay. So this is the sample standard deviation, population standard deviation. Formula is very similar. We're going to take all of our observations minus, this is the sample average. Okay, it is pronounced X bar. And so X bar, sample average. Square them, add them up. We're not going to divide by big N though. We're going to divide by little n, right? That's the number of things in our sample. It's little n minus 1. It turns out if we divide by n, we get too small of a number. So we have to kind of back it up a little bit and get a little bit bigger. That's n minus 1 is 4. And then we're going to take square roots. To get the variance, we're just not going to take the square roots. You know, it's still like happy that we still did it. It saves you a step. But we generally don't, like the homework will ask you variance, I will ask you variance. So there's our formulas. Okay. So what I would like to do next is I'd like to take you through one. Okay, so we're going to take a small one, work through it by hand, and then right after we're done, we're going to work through it on the computer, on a calculator rather, so that you see how they relate and you can see what to do with it. So I'm going to take a very easy sample. Take my sample in 1, 3, 5, 7. Just to calculate by hand. Sample standard deviation. By the way, if they never say, like if they forget to tell you it's a sample versus a population, you should always assume sample. They don't say population, assume it's a sample. Samples are easy to get, populations are hard. Okay, so just be a little bit careful about that, but they don't say assume it's a sample. You can always ask, but maybe you don't have somebody there to ask. a subsample. One of the things we need to do is we need to get the average here. Okay? So what is the average of these numbers? So what is x bar equal to? Just so you guys can see what's going on here. Have 1 plus 3 plus 5 plus 7 plus 9 is equal. How many numbers do I have? 1, 2, 3, 4, 5 values. So we take 25 divided by 5. You didn't really need a calculator for this, but some of you do. It's okay. Get there. So my sample average is 5. So the next thing we're going to do is we're going to take our xi's. That's the one. First, right? X1 is 1. X2 is 3. X3 is 5. So it's just in order. This is the first one, second one. So x5. So xi minus x bar. So just real slow. It's 1 minus 5, 2 minus 5, 5 minus 5, 7 minus 5, is 5. What are these equal? Okay. It's 1 minus 5. That's minus 4. That's minus 2. 0, 2, 4. Next step. So we're going to take this value here. Remember the formula? So we're going to square them. Square. So you have to be a little bit careful because in your calculator, if you take minus 4 squared, you both know that square number is always going to be positive. But they told me negative 16. You were smarter than the calculator. We are. What the calculator thinks you meant, was take negative 4 squared. And it does order of operations. Exponents come before multiplication. So it squares the 4 and then adds the negative sign in for multiplication. What you meant was parentheses minus 4, parentheses squared. But we know what negative 4 squared is. It's 16. So we're just going to write that down. Negative 2 squared, negative 2 times negative 2, that's 4. 0 squared, that's 0. Just in case anybody ever asks you to take the square root of 0, it's also 0. 2 squared is 4. 4 squared is 16. Then we got to add these up. So 16 plus 4 plus 0 plus 4 plus 16. So this 2 is 20. This 2 is 20. This was 0. We end up with a total of 40. Okay. So we are at this point in our formula. Get this difference, we squared them, we added them up. Now we're going to divide by n minus 1. So we're going to take 40 divided by, how many numbers do we have? 1, 2, 3, 4, 5. So we take 5 minus 1. It's better known as 4. Yeah, 10. The over 4 is 10. What's the next thing we get? You have to take the square root. Okay, so s is equal to the square root of 10, okay, which is approximately, we're just going to go 2 decimal places here. But we're going to go ahead and take the second function, square root, 10, 3.16. That, if you had to do this by hand, I will not ask you. You have to do this by hand. That is how you would do it. Now, you're not going to do this by hand. We might do it one more time in an example. This is it. Okay. What you're going to do is you see this little stat button off to the side here? Stat. And you're going to be in an edit. It's asking you to give it a list. I'm going to go ahead and clear my list before I start. When you want to get rid of your list, use the clear list. Oops. Clear list. Clear list. And it's asking me which list do I like to clear. And I'd like to clear list 1. That's the second function. 1. So the little yellow L1 here. That's what I'm clearing. Great. Done. So we're going to go back to stat. We're going to edit that list. I want to put some stuff in. Do not, please, do not delete the L1, L2, L3. Can't, it'll let you do it. But I don't know how to undo that. There is a way, but I don't know that this calculator. I've been working. So there is a way to do this, but I never get it. So don't mess with L1, L2, L3. If you do, I'm sure you can YouTube. I'm sure you can take it to if you borrowed it from the calculator, borrowed from the CNN library. I'm sure you can back. So we're just going to go. You put the numbers in. I'll put 1, 3, 5, 7, and 8 in here. So 1, 2, 3, 2, 5, 2, 7, 2, 9. If you would have rather used the arrow keys, those will work too. Right? Once you have your numbers set in here, we're going to do stat. Move over to where it says count. One variable statistics. You're going to choose this almost all the time. The only time you're going to choose 2 variable statistics is in chapter 4. Okay? But 1 variable statistics. And it's asking, what list would you like to do this? If you just press enter, it assumes the first list. But we'll say second function L1, enter. And it's got all sorts of stuff that we're going to use here. So here is our average X bar, right? Then we're not going to need these numbers. In more advanced classes, you will. Not this one. Okay, SX, right? Remember we said that the sample standard deviation was S? The calculator is leaving room when we're talking about 2 variable statistics. So sometimes an X and a Y could be here. So we have standard deviation for the X's and a standard deviation for the Y's. So they say SX, we don't have a Y. They still use SX. It's 3.6. Hey, look at that. This next one, sigma X. So that is, that's a little sigma X. That was the population standard deviation, remember? And it's different because they divided by 5. They divided by 5, not 4. So you can see it's not a lot different, but it's a little different. Different enough that we can tell. So we know which one you used. So be real careful about that. When I ask you, tell me the standard deviation, tell me the sample standard deviation, you are not going to just vomit out the contents of the calculator. I don't want you to just write down every calculator told you. I want you to tell me this one. Or if I ask for population, I want you to just tell me this one. I want you to tell me both. It's up to you. No, your answer. Now we can go down, okay, and they give us some different stuff here. We'll get into what these mean, what these are for in a little bit. But for today, all you really care about is SX for sample standard deviation, sigma X for population standard deviation. Now, what if you want the variance? What if I wanted the variance? Because your homework will ask. Okay, I won't, but the homework really cares. Okay. So what you're going to do is we're going to say, so what we're going to do is we're going to square it. Okay, so if I wanted the variance, it would be 3.16 squared. Right? In this case, we write down 10. It's only because we know. We have 2.828 squared, right? The sample variance. So sample variance is 10. The population variance was 8. So your numbers are usually not going to be this clean. I'll show you that as soon as we do an example. That's how you figure out a standard deviation by hand, which you will not be doing. Okay, I've had several students in the past that later in the class, there's a problem where it says, hey, you have to need the standard deviation to do this technique. And there's 12 numbers, and they go through this. And it's like, no, This is not the kind of class that it was in the 1970s, 1980s, 1950s. Like, we are 21st century now. We have the calculators. We don't have to spend all of our time doing this. Even if we did, the point of the later questions, the point of the later chapters is to quiz you on the material in the later chapters. It's not to waste 3 hours of your time doing this. Okay, it's not where you're supposed to be working. Okay? That have things to do. So you should be using your calculators to get your variances, to get your standard deviations on your home. Speaking of which, let's do a few. Okay. So I have, and change some of these. I'm sorry, change them. But here's our copy of homework 2, standard deviation. Go ahead and preview our assignment. You're going to do it. I have to preview it. Choice to do, just do it. Okay, and let's see here. Only 10 problems, thank goodness. All right, it's good. Let's do 2. So here's my data. It does not have to be in order, although I would like to be in order. It's one thing I can't stand about stats books, and all of them do this. I think bugs the heck out of me. You were old enough to know, right, that you were old enough to know that 6 is a smaller number than 23. Yeah, I don't know why they don't just tell you what the order is and put these in order first, but they don't. Very few statistics do this. So part of the job here, in this case, you don't need to put them in order, but oh, this is a population. See, they say population, right? So you have to work. So what do we have here? 1, 2, 3, 6 numbers here. So we have 6, 7, right? 6, 7, 17, 19. 22 and 23. So this is a population problem. Right? So we're using formula for sigma, right? Which is going to be xi minus the mean squared, sum out of that total, square root. Again, you're going to be getting this out of the calculator. Not going to ask you to do this by hand. You probably should not memorize this formula. Actually, I don't really want you to memorize any formulas. Okay, I'd be happy to put formulas on the exams for us. You'll never have to memorize them. It's not. That's another thing that gives stats a bad rap. It's like, memorize all the formulas. No, you don't. You look them up. Don't. But I'd like to do one more by hand just to kind of show us, like, I picked an example that wasn't so carefully planned out. Okay, so 6, 7, 17, 19, 20. Great. Now, first thing we did, right, got our mean. So remember, this one is called mu. This is the average. So let's get the average here. So we have 6 plus 7 plus 19, 17, 19 plus 22 plus 23 equals, and we're going to divide by 6, right? 1, 2, 3, 6. 6 equals 15 and 2/3. Now, let's check this. What did they want us to do? Round to 1 decimal place. So what I'm going to do is I'm going to do what they call intermediate calculations to 2 decimal places so that I can round when I'm done. So this is all going to be two decimal places in my work so that my last decimal place when I'm rounding my answer will be accurate. So what we're going to do here is we're going to say 6 minus 15.67, 7 minus 15.67, 17 is 15.67. 19 is 15.67. 2 is 15.67. And 23 minus 15.67. This is exhausting already. All right, so what we're going to do, 6 minus 15.67 is negative 67. I'm going to go ahead and square it while I've got the number easily available. Okay, because that's our next step anyway, is to square them. So let's go ahead and do that. We get 93.5. So this is going to be, see 93, E93, 93, 5, 2 decimal places, the 8 rounds up to 1. So 93. This is going to be 7 minus 15.667. Be careful. That was 8.67. Square it. We have, this was negative 8.67. When I squared it, right, it was 75.17. Right? I just want to make you appreciate that living in the 21st century means that the calculator, we used to actually have to do, you know, if you had a high school class like in the 80s and you had to do statistics, I said, no, you don't get to use a calculator. You get to do this all by hand. Trust me, it's delightful. Minus 15.67. Okay, so this was, actually, I did not get to use a calculator until I took chemistry. And even then, I had to wait until my mom had to go to like parent-teacher night. And the teacher actually had to convince them, it's like, no, they need a calculator for chemistry. Okay. So this just thought it was like a fiendish plot of mine to get out of doing it. I was not great at high school. I say that he was not great. I'm just saying that. I remember my geometry class started with 28 kids or whatever it was. And class, it was me, this other girl in class, only 2 people left. Everybody else had either arrested or dropped out of school. Next year, I took algebra 2, so 12th grade, I took algebra 2. 622 minus 30 squared. I got, so there's only 2 people left in my cohort. And they moved us up to the class with the football and cheerleaders. So I voted to be in the joint class. Now, I'm not going to say some cheerleaders can't be coaching. It's weird who ends up actually being the manager. There's quite a few sports people. But yeah, it's not that they can't be intelligent. There is a stereotype for it. So here we are, right? We added up all these things. Some story time in. We're gonna add these guys up. So this is 93.75.7 plus 1.77 plus 3.7 plus 53.7 equals 264.25. Okay. By the way, one thing I am incredibly sorry about. Asked Connect Math to do this for us. But it's that They go through the problems and they write down what the answer should be if you've done it. But they allow for like 0 minor mistake. Okay, so you don't do this right, it tells you you're wrong. It's like, but I had 0.2 rather than 0.3. They don't care. Point, it's not this number, it's not 262.3. They will mark you wrong. So we added up, right? So we're at the point here, we've done this. We've done x minus mu squared. What's left? We have to divide by n. So 1, 2, 3, 4, 6. Remember, it's a population, so we divide this number to 64.25, 6. Okay, it's crossed, hope for the best. 6. 40. What's that? 04. 40.04. Okay. So to 1 decimal place, that's 40.0. This is my variance. So remember, it's sigma. Sigma squared, that's variance. Okay, so my symbols of sigma, though, is a standard deviation. So why don't you use the square root symbol instead? The square root symbol is hard to write. Again, enjoy the 21st century. Typesetting, the 1900s, 1960s. Like this was not a fun thing to have to typeset all the time. So, like this. Go back earlier, this was not a fun typeset. So that's why we use this. Take the square root, so second function, square root of the answer. So it's second function. You see this little a and s down at the bottom? Whatever was the last thing in the calculator, that's what it puts in there. So this a and s is really 44.666. Then sigma, take the square root of this thing. This was 6.636, so 6.6 to 1 decimal place. Okay. So we're going to type those in, hope for the best. So see here, population variance, 40. Let's see if it takes that. And population standard deviation, this one is 6.6. Fingers crossed. See, the smarts would do this on the calculator right now. Double check it before you type this thing. And they said no. Let's test. Let's see what we actually should have got. Okay, so we're going to go to stat, to the list. They didn't tell me why. Bastards. Now let's go ahead and put these in the list. So let's see here. We've got stat at the list. We're going to put them in. So 17, enter, 7, enter, 19, 2, 6, 2, 23, 22. Let's inspect. 17, 7, 19, 6, 23, 22. Good. Right, and we're going to go to stat again. For the calc, unvariable statistics. Okay. On, what are we doing? Just one. Enter. Boom. So, okay. Maybe I should have kept a couple places. So we have 6.67. Let's go ahead and try again. This one's 6.7 now, right? The 2 decimal places. So do just 1 decimal place. That's okay. So, oh, 6.8. It's really off. And then what we're going to do is we are going to type this value here. 6.774. 6.7741. 6 squared at 45.9. It's so off. It's hard to see it. I have a feeling so many guys are like, it's right there. Yeah. Hooray! So rather than go back, check off my arithmetic here, sure we could. But we're not going to be required to do this by hand. That's the procedure, but we're not going to do it by hand. So let's do a couple more. So actually, let's save some examples for the next video. So this one's getting kind of long. So I will be right back with a new video talking to you about some of these other ones. We will again do more calculator exercises and see. Okay? So, all right. So there we are. Some more standard deviations, and I'll be back in the next video.